Hi, Professor Dyer here, talking about research in human development and family science. Today, we are still talking about science, specifically the process of scientific publishing. Scientific publishing is about meeting one of the defining characteristics of science, which is that science must be publicly verifiable. Before we go too far, why? Why must science be publicly verifiable? The truth is, science is a group endeavor. Do you remember all those biases we talked about in human perception and cognition, and the fact that we use systematic empiricism and falsifiability to try to mitigate those, to try to avert them? We do a great job, but the truth is, individual scientists are all located in a specific social position in their world. Their biases are all shaped by their positionality in society. So individual scientists are all biased, and individual studies themselves all have limitations. Now, this is because we're using empiricism. Empiricism means direct observation of the world. Any place that you do a direct observation of the world is one particular place in the world that you're observing, and empiricism requires us to use inductive generalization to try to generalize beyond that population. Multiple studies will be necessary if we're ever going to generalize beyond particular narrow populations. We have to pool what we know and see if we're finding the same thing, essentially. As a result, no one study is ever the answer to a question. Scientists look at the body of research produced by multiple scientists using multiple methods with multiple samples in multiple locations. And when we have that kind of data set, then we can arrive at scientific consensus. But we don't do it alone. How does the scientific community manage to publicly verify the works of science? First of all, every scientific study has to be based on prior published research. When a scientist writes the results of their study in the literature review at the beginning of the paper and in the discussion section at the end of the paper, they must describe, or they won't be able to publish the results. They must describe how that research is grounded in prior published research. Secondly, the process of submitting a paper and publishing it includes something called peer review. Essentially, a journal will have an editor who receives manuscripts. That editor must find experts in the field, people who have already published research on that topic, and the editor sends the manuscript off to a few of those folks. Typically, the peer reviewers will write comments, say, I'm not buying this part here. Do you have any more evidence? Can you back up this statement with any other evidence? Or I think maybe you've missed the research by so-and-so who has dealt with this at length, and I need to see that you are aware of that. So they send back extensive comments. If the author is lucky, a lot of manuscripts just get rejected right off the bat. But if they're lucky, the reviewers send really thoughtful comments, and then the author has to see if they can respond to the comments and get the paper to the point that it's satisfactory. Eventually, hopefully, it gets published. It gets published in a professional journal. Professional journals are maintained by public libraries. They have searchable databases so that other scientists then have a way to find that study when they are looking for background information on a new topic for them. And journals typically keep track of citations, so they know that this particular research finding has been cited by future scholars looking at this issue or that issue. Finally, when papers are published in scientific journals, the methods section is often quite long. The methods section must include enough detail so that if someone else wants to repeat or replicate the study, they would have enough information to do so. Similarly, in the results section of a scientific paper, sometimes statistics are presented not because they're terribly helpful to the reader, but because if anyone was ever going to replicate this study or do a meta-analysis, including that study, they would need some of the fine details of the statistical results. So these are the three main strategies that science uses to make scientific findings publicly verifiable. Let's go back to this case, this person who said in the 90s, I can help teach your baby to read. Your baby can read, it says right there. Has this been verified by science? Is this a publicly verified, approved by a community of scholars claim? And so one of the ways we can find out pretty easily is I went into PsycInfo, which is a database that indexes psychological research, and I also included ERIC, which is a database that indexes educational research. And what I found when I put him in there as the author and included baby can read, no results found. He's never, ever published anything about whether babies can read. I searched again, and I just searched his name, but I took off the baby can read. Has he published anything? Has he ever done any science? And what you could see if you looked carefully here is he published his dissertation, that's number 3, but he's never published anything about reading, about instruction, about learning, never published anything even remotely related to this. So the concept that babies might be able to read is not empirically grounded.